Started work, energy and power. If some school have finished work, energy and power, then leave that school and go to some different school. Because that much fast is not possible. Up to starting of work, energy and power also I can accept, they can. But I don't think any school can finish Newton's work, energy and power and start rotational mechanics. Otherwise not. So, today we are going to start one of the important chapters, very important chapters, where for school level it is small, not much is there, and what is there is you can understand easily, I believe that. But if you are preparing for any competitive examination, if your aim is any NEET or JEE or anything, this chapter becomes very important, especially JEE aspirants. If you are engineering aspirants, then laws of motion, expect 1 or 2 questions to come in the JEE examination. If you are a NEET aspirant also, definitely question will come from here, 1 or 2 from laws of motion. So, laws of motion becomes a very important chapter. Some of you who were already there in the bridge course have learned some basics of laws of motion from me already. So, for them it will be like kind of revision today. But those who are not there in the bridge course, for them it will be the first time learning. Also, today I am going to definitely go beyond bridge course. Whatever you learned in bridge course, I am going to go beyond that. So, it is going to be a takeaway for everybody who is there in the class today. Just one thing you should remember is that now whatever we are learning, you have to parallelly keep on doing all the worksheets that is given in the other class. Like you are getting worksheets on every Friday if I am right. Whatever worksheets you are getting in your hand, whether it is projectile motion worksheet, laws of motion worksheet will come next class tomorrow, and whatever the earlier worksheets that you have got, please finish it. Solve NCERT question, finish it. Get your doubts clarified either with Alamelu ma'am or me, whoever. But until you sit and solve question at home, whatever I am teaching here will become a waste of time. Be reminded of this. Your whatever I am teaching here will be useful for you only if you are practicing question at home, because whatever practice I am giving in the classroom is not sufficient to become expert in any topic. It will make your concepts clear, but to become good in a concept, you have to solve questions back at home. Okay. So, with this, let us start today's class. And today, this chapter, all of you can give the heading as, the chapter name is Laws of Motion. So, this chapter starts with the first topic, and the first topic is recall of 9th standard, which is basically understanding the concepts of inertia and momentum. So, first topic in this chapter is understanding inertia and understanding momentum. So, what is inertia? Anybody has any idea about that? Inability of an object to change its state of rest or motion. I think by now everybody knows this, because you are studying in 11th standard, and in 9th you already studied that inability of an object to change its state of rest or uniform motion is known as inertia. Not only rest or motion, even direction. It means if an object is having a particular state, it wants to be in the same state. That is how the body is, it is lazy. It wants to be in the same state how it is. If this plank is kept here, this plank wants to be here only until or unless some external force is acting on it. So, always remember that any object in state of rest or uniform motion, that is the first law of motion, I will talk about that, will remain in the same state until or unless an external force acts on it. And this property of not changing the state of rest or motion, this property only is called as inertia. Inertia is of 3 different types: inertia of rest, inertia of motion, inertia of direction. For your knowledge, inertia is not a quantity, rather it is a property. In physics, I said you will be studying, you will be coming across lot of terms. Some of them, most of them will be quantities and few of them will be properties. Properties will not have any units. Properties will not have any equation or the formula or dimensions. It is just a property. So inertia, if I ask you what is the formula of inertia, you cannot say the answer itself, because there is no formula of inertia. Even though inertia depends on mass, we don't say that the formula of inertia is I is proportional to m, I is equal to k into m, nothing like that. It is true that inertia depends upon mass, but we don't define any formula or we don't define any equation to define inertia. So remember, inertia is a property which enables an object to continue in the state of rest or continue in the state of motion. So it is the inability of an object to change its state of rest or motion. Even the direction. How the question can come from here? One very basic question, if your luck is good, can come like, there are two objects, two balls are there of same radius. One ball is made up of wood, one ball is made up of steel. Which ball has more inertia? Obviously steel. Because same volume, steel will have more mass because it has more density. So you can easily say the answer is steel. This question will not come, by the way. Next question will come like examples of inertia. They won't ask example of inertia. They will give you an example and they will ask you which inertia is this. For example, you are sitting in a bus and bus starts suddenly. It is example of inertia of rest. You are sitting in a moving bus, bus stops suddenly. It is example of inertia of motion. You are sitting and the bus is turning in one direction. Inertia of direction. I am having a cloth of having dust and I am hitting the dusted cloth with a duster. That is the inertia of rest. If you have a cloth and we have a vessels on that and I suddenly take out the cloth and the vessels are not falling down. Inertia of rest. Are you getting? So you will get some examples and they may ask you which inertia is this. You should be able to define it is inertia of rest, inertia of motion or inertia of direction. Very basic. Then comes, yes, please tell me. Difference you are asking. See, in a question, if an object is at rest and it remains in rest, that kind of example can be inertia of rest. That is, if you try to change its state, it will give some opposition. For example, you are sitting in a bus and the bus starts, you will get a jerk, right? So you are at rest, your body wanted to be at rest, but because the bus started, you came to motion. That is inertia of rest. If in a question, the object is already in motion. Suppose there is a moving car and a person is sitting inside the car. So object is in motion already. Driver applies the brake, car stops, the body will give jerk. Understand, this is the inertia of motion. So in inertia of rest examples, the object will be at rest and we will try to bring it in motion. For inertia of motion example, object will be in motion and we will try to bring it in rest. Inertia of direction, object will be in a particular direction, we will try to change its direction. Are you getting a point? So that's how you identify whether it is inertia of rest, inertia of motion or inertia of direction. Very simple. Then comes, since we learned about inertia, parallelly we can learn about the Newton's first law of motion also. Not much comes in the exam because you are in 11th standard, but then also you must know the statement of first law of motion. All of you please write it. Those who are writing for the first time, how is it defined? Newton's first law of motion. Please write a definition. Any object in a state of rest, or uniform motion, any object in a state of rest or uniform motion continues to be in the same state, until or unless an external unbalanced force acts on it. Unbalanced force acts on it. Okay. What does it mean? It means the same thing. Like this bottle is there. This bottle is at rest. It will remain at rest until I give some force to it. So, do you think that this bottle will move by itself at any cost? Never it can move. If it starts moving, then what you should do? You should also escape from there, right? Bottle is moving by itself, what you will do, man? Run away immediately. Okay, anyhow, that is... Okay, sorry. We stand and fight with the ghost. Okay, anyhow, so there is a bottle, and the bottle is having a capability of moving only if I apply a force. What if I say that force is applied and the body does not move? Is it possible that a force is applied and the body does not move?
So an equal opposite.
Yes, if I apply a force like this and a force like this, the force is applied. Did the body move? No. It means it is a balanced force. What, Srinidhi? Please come again.
When net force is 0.
Exactly. For any object to change its state of rest or motion, we need a unbalanced force, or net force should be there, as Srinidhi is saying more technically. I am using layman's word, unbalanced. He is using technical word, net force. Correct. If net force is not 0, the body will move. Net force is 0, how will the body move? So there is an object, you are applying a force of 10 Newton from here and same 10 from this side. The body can never move. Yes, one thing can happen, the body shape, size may change, but the body will not come to rest or motion, because this is the example of what force? Balanced force. So as the definition says, any object in a state of rest or uniform motion will change its state if there is a unbalanced force acting on it. Are you getting my point? That is very important, very basic thing which we learned in some other classes. Okay. To understand the second law of motion, you must understand the concept of momentum. Have you heard about this word momentum? What is momentum?
Product of mass and velocity.
Good. Is it a vector quantity or a scalar quantity?
Vector.
It's obviously a vector quantity.
Vector.
Yes, and it is product of mass and velocity. Please write it down in the notebook. Momentum is the product of mass and velocity. Momentum is the product of mass and velocity. Momentum is the product of mass and velocity. Sorry. What will be its SI unit?
kg meter per second.
Common sense says it is kilogram meter per second. What is its dimension?
MLT minus s.
Once again, mass is m, velocity is Lt power minus 1. So MLT power minus 1 is the dimension of momentum. Very basic thing I am teaching. These things you are studying in very small class itself, except dimension part. Slowly I will go to higher level. Okay. After understanding what is the meaning of momentum, let us try to understand what is impulse. What is impulse? Any idea? Force into?
Force into time.
Okay. So, force into time. Correct, you are very correct. Any other definition of impulse?
Change in motion.
Change in momentum, somebody told. I was expecting that. Good. So, this both are correct. Force time or large force, small time is almost same. Impulse is not only force into time, it is also change in momentum. We will understand that now. First, write definition of impulse. Impulse is when a large force acts for a short duration of time. Impulse is when a large force acts for a short duration of time. Large force acts for a short duration of time. So, we generally write impulse as f dt. Why dt? Small time. That is why dt. So, dt denotes a small time. So, what will be its unit? Force is in Newton, time is in second, so Newton second, isn't it? Do you agree with me? And what will be its dimension? Force is mLt power minus 2 and time is t, mLt power minus 1. What was the dimension of momentum? Same.
Inverted power and
Yes, it means that momentum and impulse have same dimension. It means they are same quantities actually. Impulse is a kind of momentum which acts for a short duration of time. I'll tell one more thing to you. See here. Impulse. What is force? Force is equal to what? Mass into acceleration. And it is dt here, isn't it? What is acceleration? Rate of change of velocity? dv by dt into dt. The two gets cancelled. Don't you think we get impulse as mdv? What is the meaning of dv? Change in velocity. Change in velocity. So I can write impulse is also given as mass into change in velocity. If I write in more simple way, I can write mass into final velocity minus initial velocity. So impulse will become equal to mv minus mu. mv can be written as final momentum, mu can be written as initial momentum. So I can write impulse as final momentum minus initial momentum. That is why its dimension is same as momentum. So if somebody asks SI unit of impulse, you can also say kg meter per second. Apart from saying Newton second, it can also be represented in kilogram meter per second. So impulse formula is force into time, also final momentum minus initial momentum or change in momentum. I hope it is clear to you. Is it clear to you? Yes. Momentum. Momentum, I said it is the product of mass and velocity. Don't know here. Definition what I am telling, man. Momentum is the product of mass and velocity. Definition also comes like this only. It's not like something else is there. Rate of change of? That is for second law of motion, man. We'll come to that. Rate of change of momentum is applied unbalanced force. We'll come to that.
No, change in momentum, the expression short duration or is impulse.
Impulse, yes. Have you copied all these things?
Sir, no, sir.
Make it fast, Thambi. Make it fast. Sahitya Shri, your problem of internet not solved? See here, attending class without camera is not at all advisable. I am not able to hear you, be louder at least.
Tomorrow it will be fixed.
Very good. Tomorrow it will be fixed. Madesh Raj is on in the camera. Avinash, camera should always be on in the class. Kirtish Kumar, Akash Murli, you people are new for this. So maybe you are not knowing the rules properly. The video should always be on. I will meet you tomorrow in the school. That time, maybe I will tell you more stressfully that it is important to have the video on, because it's not simply I am teaching in phone here. It is a proper setup of online class where we are monitoring you, your activities. We are checking whether your eyes are in the screen or not, or you are seeing something else. So we have a proper analysis of how much you are studying. It is possible only if you are in the camera. Otherwise, you are studying, or you are eating, or you are sleeping, or you are going to play football. We don't know. That's why we want you to have your video always on. Please, online students, understand the importance of being in the camera on in the online class. Coming back. So, one very famous question from impulse, school level as well as competitive level. It comes, I have seen anywhere it comes. The question is, there is a wall. It's a famous question. It's there in NCERT also, I think. Example. There is a wall and there is an object. Suppose there is a ball. Okay, having a mass of 2 kg, coming and hitting the wall. Okay, so it is coming and hitting at an angle of 30 degree, and after hitting, obviously it will bounce. It bounces like this, making the same angle of 30 degree. you are supposed to calculate the impulse. Mass of the ball is 2 kilogram and its velocity also is given actually. Its velocity is given as, take 10 meter per second. Its velocity is 10 meter per second. Moreover, after it hits the ball, it goes. That time also its velocity is 10 meter per second only, because I am assuming the collision is elastic. And you will study in the work energy and power, if the collision is elastic, the velocity does not change after collision. Okay? That is, initial velocity and final velocity are same. That collision is called as elastic collision. So, since the collision is elastic, what is the velocity with which the ball is coming? The ball is going with the same velocity. Now you calculate the impulse fast.
Zero.
Think and say.
Zero.
Okay, let me tell you. Guys, guess fast. Loudly. 20 meter per 20 kilogram meter per second, if you say also. Yes, let us check. I am not sure whether answer is right or not. Others, your answer, you have got any answer? If it is this simple question that the answer is 0 or the answer is 20 kilogram meter per second, I will not give this question itself. This question has something, that's why I stressfully gave this question. It's not that simple as you are thinking. 30 degree simply I gave. Lilith Ramana? Why? Chuma? புரியல இதே கொடுத்துருக்காங்க சும்மா கொடுத்துருக்காங்களா புரியல சத்தமா அதான் கண்டபுடி then only will get the marks. Shall I help you? First question of this kind? Zero definitely not.
20 kilograms per second.
No way. 20 kilogram meter per second is impossible. 0 is also impossible. 40. Something blabber. Okay, coming back. This kind of question how to solve? I am saying you this question comes in school level. This question comes in competitive level also. Simple question, but I will explain you. Please pay attention. So now, in this question, what they gave you a surface and they told that there is an object of mass 2 kg coming and hitting the surface, and they gave the angle at which it hits is 30 degree, right? And then it goes in this direction, making the same angle of 30 degree with the vertical. First of all, momentum you said before some time is a vector quantity.
Yes, sir.
Vector quantities should always be resolved. Remember this. It will have two components. One component here, one component here. Are you getting my point? And how much will be the components? 30 degree. I can write this, it will become equal to, suppose, what is the momentum here? As you said, momentum is mass into velocity. So, mass into velocity is how much? 20 kilogram meter per second. But what is the momentum in this direction? Let me call it as momentum in y direction. 20 cos 30. I hope you know this.
Yes, sir.
Are you aware about this concept? And this will be 20 sin 30. Are you aware about this thing? Are you aware that if there is any vector quantities, velocity, momentum, force, acceleration, anything, making an angle of theta, suppose it is x, this will become x cos theta, this will become x sin theta. If it is theta here, this will become x cos theta, this will become x sin theta. If it is theta here, this will become x cos theta, this will become x sin theta. I mean to say that which side theta is attached, that will become the cos component, opposite will become the sin component. Tell me. Y sin theta and y cos theta are coming. You are asking me why it became x sin theta and why it became x cos theta. That is the question.
x-axis எப்படி x cos and sin, y-axis
அப்படி இல்லை தம்பி, நம்ம வந்து we are not saying x axis as cos and y axis as sin. Here I told y as cos and x as sin. So it does not depend upon x or y, it depends upon which side theta is attached. If theta attached in the y axis, then this will become cos component. Y upward layer, y axis man, x I am taking some displacement, not x axis, x is some displacement. Concept is which side theta is attached, that side will become what component? Cos. And which side theta is not attached, that will become sin component. So we came to know that there is momentum acting in this direction 20 sin 30, this direction 20 cos 30. Once again, here the object had a momentum of how much? Same 20 kilogram per second, 20 kilogram meter per second. So what will be its resolution? This will become 20 cos 30 and this will become how much? 20 sin 30. Do you agree with me?
How does the other side 20 kilogram?
How this 20 kilogram, how this came you are saying? I assumed collision is elastic. Elastic means velocity remains same. What velocity it came? Velocity remains same. 10 it came, no? 10 remains same, 10 and 2 mass is 2. 10 into 2 is 20. How 20 came here when same way 20 came here also? Are you getting a point? Momentum is mass into velocity. Mass is 2, velocity is 10. How much is the momentum? 20. But 20 is in this direction. If you resolve in horizontal component and vertical component, it will change. Now, in this case, the impulse will be different in x direction. I am writing the impulse in x direction as Ix. That will be change in momentum delta p in x direction. What will be that? What will be that? Initial momentum into final, we have told before some time that impulses change in momentum, isn't it?
mvx.
Yes, that will become equal to mvx minus mux. Do you agree with me? So in x direction, what is the value of mv final? 20 sin 30. One more thing is there here. Please pay attention. Something very important we are learning. It may confuse you. If I take this direction as positive, this must be negative, or vice versa. If I take this as negative, this must be positive. Okay? What do you want to take? You want to take right as positive and left as negative. Shall I take it like that? So in that case, it will become minus 20 sin 30, isn't it? Final. And then minus 20 sin 30 again. Do you agree with me? What is sin 30? 1 by 2. So minus 10 minus 10. Answer is minus 20 kilogram meter per second or Newton second, whatever you want to call it. Only in x direction. Same way, what will be impulse in y direction? I y will become equal to delta py, which will be momentum in y direction minus initial momentum in y direction. What is the value of final moment in y direction? 20 cos 30. So both are in the same direction. So I am taking down as positive. Both are positive down only. So 20 cos 30 minus 20 cos 30. How much is that? So impulse in x direction is minus 20 kilogram meter per second and impulse in y direction is 0. Is it clear to you? It's an important question. It's a deep question. If you have any problem, ask me now. This kind of question can come in school level itself. Loudly? Same thing will happen. It will become positive. It will become 20 sin 30 minus of minus 20 sin 30. It will become 10 plus 10, 20 it will become.
How can we say which component is x, which is y?
In the sense, I am taking x as horizontal and y as vertical. Your wish. If you don't want to write x, y, you can write h and v also. No problem in that.
Okay.
Your wish. Yeah.
Next component, how to prove this minus 30?
Loudly.
Next component, how to prove this minus 30?
Because I am taking this side as negative. So this 20 sin 30 I am taking as negative. And this is positive. So 20 sin 30 I am taking as positive. No, opposite direction. So we are using the formula mvx minus c. One more way I will explain you. One more easy way if you are confusing. That way will be c. Don't confuse. One more way I am explaining. Please pay attention. Now what I am doing, the same question I am doing in a different way. How I am solving? Mass is 2 kg and the velocity is how much they told?
10 meters.
Luckily velocity also is a vector quantity. So 10 meter per second is acting in 30-degree direction. So in this direction how much will act? 10 cos 30. I am talking about the velocity alone. What is this? Vx. I should say ux actually. Initial velocity in x direction. And what is the initial velocity in y direction? No, this will become initial velocity in y direction. How much is that? 10 cos 30. Here it will become 10 sin 30. Do you agree with me? What is this? Initial velocity in x direction. Same way, when the body goes in this direction, same body of mass 2 kg, having velocity of how much? 10 meter per second, and this side you have 30 degree. Then we will resolve it. Then velocity will become how much? Check. Velocity will become, this side it will become 10 cos 30. What is that? Final velocity in y direction, Vy. And this side you will get final velocity in x direction. How much is that? 10 sin 30. Now you pay attention, you will realize that if I am taking, they both are in same direction. You can assume convention like this if you want, no problem in this. You can assume convention like plus, minus, your wish. If you take like that, then these two are in same direction. So this will become minus and minus. Let me take minus itself, no problem in that. Downward. Ux is in this direction, so it will be plus. Vx is in this direction, it will be minus. Now put in the equation. mvx. What will be mvx? M is 2, Vx is minus 10 sin 30. So it will become minus 20 sin 30. Minus of mux. M is 2, ux how much? Plus 10. So minus 10, it will become minus 20 sin 30. Same answer will come. And in the case of y direction, initial is minus 10 cos 30, final is minus 10 cos 30. So you will have this will become minus, this will become plus, anyhow answer will come 0 only. What confusion you are getting? This direction confusion you are getting. What is the problem, man? I am taking this, all the things in this direction as positive, in that direction negative. Man, here it is in downward direction, right? Downward is what direction? Which one? Vx is negative. Vy is negative. I wrote both. Yeah, ux how key varada thambi? Ux inda pakkam varadalla. Hey, uy only coming down. Or negative than I have taken minus 10 and the cos 30 only, no? Downward negative, right positive, left negative, downward negative. There is no upward here. Are you understanding this? What is the problem you are having? This 10 I am resolving in two components. 10 cos 30, 10 sin 30. 10 cos 30 is acting in downward direction. I am assuming downward as negative, upward as positive. My wish. So this one is negative, so it will become minus 10 cos 30. This one is positive, it will become plus 10 sin 30. This velocity of 10 in 30 degree direction will resolve in two components, 10 cos 30, 10 sin 30, right? So 10 cos 30 downwards, so negative, that's why I put negative here. 10 sin 30 also negative because it is acting in this direction, left direction, negative, that's why I put negative here also. Understanding? And then putting the value of Vx, Ux, Vy, Uy, getting the answer. Whichever way you want to understand, it's completely your wish. But this is how this question has to be solved. Is it clear to you? Sure? Can you go to the next concept then? Shall we?
Yes, sir.
This is about momentum and change in momentum. Now you define Newton's second law of motion. Please write it. If you are done with this, if you want 2 minutes time, take 2 minutes time and copy this. If you want 2 minutes of time, take 2 minutes of time and copy this.
Sir, on the plane and it's on the computer. If I'm there in the coordinate
Yeah, Karthikeyan.
Then that one V is equal to minus 10 side 13. Sir.
Yes.
Sir, if it goes in right side, then it is
Positive.
negative,
Positive, man. Here I have drawn no man for you. See here. Right side positive, left side negative, right?
sir. Okay.
So ux is in right side, so positive. Vx left side, so negative.
Okay.
Can I go to the next concept? Shall I? If you have understood this, then next heading is second law of motion. Newton's second law of motion. Define that. Newton's second law of motion. Purila. Equilibrium.
Conservation.
It will come, man. After this only it will come. First, second law of motion. Second law of motion. Shall I give the statement? Rate of change of momentum. I am giving the statement, guys. Take it down. Rate of change of momentum is directly proportional. Rate of change of momentum is directly proportional to the applied unbalanced force, and acts in the direction of it. I will repeat. Rate of change of momentum is directly proportional to the applied unbalanced force and acts in the direction of it. Now please pay attention. What it says dp by dt, isn't it? Rate of change of momentum. By now you should know basic differentiation. Rate of change of momentum is proportional to what? Applied unbalanced force. If you remove proportionality, you have to add a constant. This constant is given as k here, k into f. Experimentally, Newton found the value of k. How much it came? Remember this? Experimentally, what is the value of k he found? 1. So we get dp by dt is equal to f. So I can write f as what? dp by dt. You can say f is equal to ma Thambi, only in one scenario. F is equal to d by dt of mv only you can say. After that there are what? There are 3 possibilities. What are the possibilities? First possibility is if what is constant? M is constant. What you are saying, Shrish? So if m is constant, then force will become equal to m will come outside into dv by dt. Now rate of change of velocity is acceleration, so only I will get f is equal to ma. So f is equal to ma is okay, but how it is valid? It is valid only if m is constant. What if m is not constant and velocity is constant? What happens in that case? Second case. Then I will get f is equal to v into dm by dt. What is the meaning of dm by dt? Rate of change of mass, not mass. dm by dt, it means rate of change of mass. Third scenario, if nothing is constant, both are variables, then f will become equal to v into dm by dt plus m into dv by dt. Or I can write f as, this will be ma and this will be v into dm by dt. So all 3 scenarios are possible. That is, You may have mass constant, you may have velocity constant, or you may have nothing constant. What is the meaning of this? If you understand technically, practically, see, generally, if I am having 10 kg mass, okay, and I am at rest, 10 kg mass, I am at rest. If I am 10 kg mass, no, suppose I am 80 kg mass and I am at rest. Suppose somebody gives me a force of 1000 newtons. Obviously, if somebody gives force to me, I will move. 1000 Newton force. Definitely, I will throw away. So, if somebody is giving me 1000 Newton of force and I am moving, my velocity is going to change, it is going to increase. How much will be the acceleration inside me? I can find easily by using F is equal to m into A. Force applied, you know, mass, you know, find acceleration. Once again, I will be complete. It means that whenever there is a force applied on the body and the force is an unbalanced force, it will create an acceleration in the body. Its velocity will change. It may increase or decrease. Both are possible. If the force is acting in such a way that it is supporting the velocity, it will increase its velocity. If it is opposing it, it will reduce the velocity. So, friction also is a force only, which is retarding the body. Brakes are retarding the car, but accelerator is accelerating the bike. So, accelerator means it is going to increase the velocity. Brake means it is going to reduce the velocity. But in both cases, you want to use force, isn't it? Accelerator also you want to give force. Brake also you want to give force. So, a force can increase the velocity or decrease the velocity. But if anything happens, either increase or decrease, and the mass is a constant, then F is equal to ma. Second possibility is practical example. If V is a constant and mass is a variable, possible, why not? How? I gave example that time also, I forgot. Once again I am giving. You are driving a car or you are driving a bike and you are making Lalit Ramana sit behind. Okay? Be careful. Driving a bike, be careful means, I will tell you why be careful. To let the story get over. So, Sirish is driving the bike, you are sitting behind, but you are not sitting normally. How you are sitting, you know? Ulta you are sitting. So, generally if he is driving like this, you should sit like this only, no? But how you are sitting? You are sitting like this. Okay? So, now what is happening? He is driving fast. He is driving at 10 meters per second. He is not putting brake also, he is driving. You have a curious mind. Okay? So, what happened? When you are driving, suddenly you see a balloon shop. Okay? Balloon ka kaparamati, yes. Sapad ka kapanim, yeah. What do you like? Don't take 10 minutes of time, man. Okay, you saw brownie. On road, somebody is giving for free. Somebody is selling brownie for free. You see that. You thought if I say to Shrish, he should stop, then I have to get down, I have to go, it will take time. Jump directly. From moving bike, directly you jump. What happened to velocity now? Constant. Mass changed. What will happen, you know? Naturally, your velocity will increase. Common sense, mass is reduced. But if you apply some brake and maintain the velocity constant, mass changed but velocity remained constant. This example. When you jumped out of the bike, initially the bike mass was mass of the bike plus mass of Shrish plus mass of Lalit. Okay? And velocity was 20 meters per second. The moment you jumped for eating brownie, that time the mass reduced because you are not there in the bike anymore. You are there in the world, I don't know, but not in the bike for sure. In the bike you are not there. So, in the bike you are not there, mass of bike plus mass of Shrish only is there. Naturally, the velocity will try to increase because the mass became less, much less. So, now what he will do, he has to apply some brake. What, man? Control. So, if he applies brake only, the velocity can be constant. If he applies the brake to maintain the constant velocity, this is the example for that. If he is not bothering, let him jump, I will keep on moving. Okay? In that case, the velocity will change. This is the example. Velocity is also changing, mass is also changing. Are you getting my point? So practically it is possible.
Sir, ரெண்டுமே ஒரே நேரத்துல constant இருக்கா?
Mass also constant, velocity also constant, then force will not act. I am standing here, mass constant,
Suppose 0.
velocity is 0, that is acceleration is also constant, then what is the value of force? 0. Possible, no force. Are you getting my point? If mass is constant, velocity is constant, what is the acceleration, Thambi? Velocity is constant, what is the acceleration?
0.
0. F is equal to ma, a is 0, f also will be 0, isn't it? So possible, both are constant. Then the body will not be in, or body if it is in motion, it will be in motion only. Like earth is moving with a constant velocity. So it will be in motion only, it cannot stop. If it has to stop, then Galactus has to come, somebody has to come to stop it. Force has to be applied on it, isn't it? So if some force is applied, then body will stop. Okay? If you are understanding this, then copy it fast. So we don't have the formula of second law of motion as this alone. Many think that second law of motion means F is equal to ma. It is just one part of it. It can be F is equal to ma, it can be F is equal to V into dm by dt, or it can be F is equal to ma plus V into dm by dt. All three are possible. I hope it is clear. I will give a small question to make you understand this more better. Then I will go to the next concept. Slowly we are entering into the main part of the chapter. Have you copied this? All three formula? Make it fast. Ask me, Raghav.
Last time I'm not able to understand the steps along so how we are subtracting first this direction to this direction or vice versa.
The formula is people still have confusion in the previous question, as I see from the class here. I will once again solve the previous question. Okay? Those who have understood, they can take the next question. One more question I am giving you. Take the question. Question is, make it fast. If a truck is moving at 72 kilometer per hour, if a truck is moving at 72 kilometer per hour, if a truck is moving at 72 kilometer per hour and the boxes are thrown out of the bus, thrown out of the truck. The boxes are thrown out of the truck. Boxes are thrown out of the truck at a rate of.
Sir, can you write question on the board, sir? Your voice is breaking.
My voice is breaking. My internet itself became unstable. Okay, I'll write the question on the board. Indumati giving work to me. I am not liking to write here. Okay, let me write. I wrote the question as if, what I wrote here? Truck is moving with a velocity, what I told? Moving at 72 kilometer per hour and boxes are being thrown out at a rate of 5 kilogram per minute. Calculate the force required to maintain uniform motion. If you wrote the question, those who have understood the previous question can start solving this. If you have doubt, once again I am repeating the previous question. Have you written the question now? This question is written by everybody. This question is written by everybody. I hope you wrote this. So let me take the next previous question once again. I hope everybody has taken the question. Let me solve once again the previous question. If you had doubt in that question, please pay attention. There was a wall and there is a ball coming and hitting the wall. Ball is coming at a velocity of 10 meter per second. Since it is coming, I am taking it as initial velocity. So initial velocity is 10 meter per second. But since it is making an angle of 30 degree, I am resolving in two components, horizontal and vertical. So here the vertical component is acting in this direction. If you ask me why this direction, because vector quantity like this, it will be having two components. If it is like this, it will have two components like this. This is the reason for that. Okay. So this downward will be, I am taking it as vertical, so I am writing it as u y means vertical, which will become equal to 10 cos 30. And this direction, I have the horizontal component, I am taking it as ux, and what is that? 10 sin 30. Is it clear to you what I have done? Those who had doubt in the question, any problem? Drink water and come. Any problem in this thing? Those who had doubt,
Sir.
yes, ask me.
No, not this doubt, sir. The previous question you gave, sir, can you repeat it or can you write it on the board, sir? I'm using another device because the network issue is very bad, sir.
Can you see the question now?
Yes, sir. Thank you.
I'll wait for you. Copy it fast. Is it raining outside or what? No, right? Some people are having network problem, I think. Yes, I hope I am audible to everybody. Okay. So the previous question. Please pay attention if you not understood in the previous time. So after the ball hits here, it goes in this direction. With what velocity? Same 10 meter per second. Why? Because the collision was elastic. So it is having same 10 meter per second. Once again, since this velocity is acting at an angle of 30 degree, it will have two components, vertical and horizontal. This vertical component will become Vy, which will become equal to V cos theta, which is 10 cos 30. And this will be horizontal component Vx, which will become equal to 10 sin 30. Those who had doubt in the previous question, is it clear now? This step is clear? Anybody who had doubt in the previous question, is it clear now? Who asked, by the way? Somebody asked this doubt, no?
Sir, actually,
You asked it.
the sign. I got confused about the
Up to here it is clear? No problem? Okay. Now Raitanya, next what I am going to do, I am going to put the sign. Sign, be very careful. I am taking sign as towards the right, positive. Towards the left, negative. Upward, positive. Downward, negative. If you ask me, sir, I will take opposite. I will take upward negative, downward positive. Right side negative, left side positive. Then also it is fine. No problem. Okay, your wish. Your wish, whatever you want to take the direction. Okay, now in this convention, Uy is acting downwards. Downward is negative. I will take negative here. Ux acting towards right. Ux is act right, positive. Vy acting downwards, negative. Vx acting towards left, left is negative. Clear? Now what I am going to do? Now I am going to find what is the change in momentum in x direction. This will give me impulse in x direction, because formula of impulse is change in momentum. So in x direction it will be change in momentum in x direction. So in x direction it will be mvx minus mux. Do you agree with me? Now what is m? I will take m common, m is 2. What is vx? See the board. Minus 10 sin 30. Sin 30 is 1 by 2. So minus 5. Then I will take minus. What is ux? 10 sin 30. 10 by 2, 5. Do you agree? What is minus 5 minus 5? Minus 10 into 2. Clear? Now, impulse in y direction will be change in momentum in y direction, which will become equal to mvy minus muy. Is it clear? What is m? I am taking outside common 2. What is vy? What is cos 30? Root 3 by 2. So minus 10 root 3 by 2. Minus. What is uy? 10 root 3 by 2. It will become plus now, because minus minus will become plus. 10 root 3 by 2. They will cancel each other. What will be the answer? Are you getting how? Plus minus same quantity. 0. Got it? Clear? Only thing is here, sign is little confusing, but don't confuse in that. If you ask me what if I take the sign in opposite way? You told, so I am taking like this. In my school I took right side negative, left side positive. You will get the answer in that same direction. See, what I understand by negative 20 kg meter per second, you know, I understand that the net impulse is acting in left direction. If I would have taken left as positive and right as negative, my answer would have come positive 20 kilogram meter per second. Then also it means the same. My net momentum is acting in left direction. I hope you are getting my point. So it does not matter whether we took right as positive or left as positive. Ultimately answer will be same. Minus is just indicating the direction here. It indicates that net momentum, net impulse in x direction is acting towards left. Minus does not indicate it is negative, its value is lesser, no. Minus indicates that net impulse is acting in left direction. So if some student is taking left as positive, they will get the answer also as plus 20 kilogram meter per second, which once again indicates that impulse in x direction acting towards the left only.
Sir, magnitude மட்டும் அந்த minus plus ல important.
Minus plus la tell again.
Minus plus எப்படி இருந்தாலும் அந்த answer ரெண்டுமே
Same da answer na this value will be same, but minus plus is just indicating the direction. I took left as negative, so I got the answer as negative. If I take left as positive, I will get the answer as positive only. Are you getting my point? It just indicates that my net momentum is acting in which direction? Left direction. Are you getting my point? That is the meaning of minus here. It does not mean minus means negative, subtracting, small, nothing like that. Just indicates left side. Previous sum? Got the answer? Not got the answer? I'll solve. Huh? Let us see what is the value of velocity here. Kilometer per hour. So meter per second 5 by 18. How much time it will go? So velocity will become 20 meter per second. What is the formula of force in mass is the variable and velocity is constant? V into dm by dt. V is how much? 20. What is rate of change of mass? 5 kg per minute it is. So 60 seconds. 20 it will go 3 times. 5 by 3 is 1.67 Newton. That is the answer. Yes, Shishir, answer is correct. Answer is 1.67 Newton. Anybody has doubt in this what I have done? Loudly. Why are you speaking like husband? Sir, sir, 5 by 18
எப்படி கண்டுபிடிப்பீங்க?
fully you should speak. 5 by 18 எப்படி கண்டுபிடிப்பீங்க? ஆமாம் சரி. அப்போ பலகம் சேஞ்ச் பண்ண தம்பி, இது தப்பான பலகம். Okay, my Tamil is like this only. Don't get hurted. Okay, anyhow. So 5 by 18 how it came? You not studied 9th standard, no? Directly came to 12th, 11th standard. Okay, see, kilometer per hour thambi, I am converting into meter per second. 1 kilometer how many meter? Why doubtful? 1000, say loudly. 1000 meter, good. 1 hour how many seconds? Loudly.
360.
Huh? Very good. 60 into 60 is 360 for you. 60 into 60.
3600.
Good. 1 hour is 60 minute. 1 minute is 60 second. Correct? 0, 0, 0, 0.
10 by 10.
10 by 36. 2 3s are 6. 2 5s are 10. 3 into 6 is
10 by 18.
good. Understood how it came? Understood? Whenever you are converting kilometer per hour to meter per second, you multiply by 5 by 18. Whenever you want to convert meter per second to kilometer per hour, 18 by 5.
The kilometer per minute.
Kilometer per minute. அப்படி பண்ணணும். Hey தம்பி. Kilometer per minute to what? To what, man? To what? Minute per second, meter per second or millimeter per hour? Meter per second, right? Same concept. 1 kilometer how many meter? 1 minute how many second?
60.
That's all. 0 0 gets cancelled. 2 3s are 2 50 50 by 3. You are playing with me? Shall I proceed further? Is it clear to everybody? Shall I proceed further? Take 2 minutes and don't take my life. Okay, I'll proceed further. Now we are going to learn something very, very, very important. Very important, I'm saying. Whatever school exam you're going to write next, question will come from there. Okay. So it's an important topic. Give the heading as Equilibrium of concurrent forces, important topic. Okay, before that I should tell you about one more thing here. Common search forces. Okay, that will take next class. So, give the heading as equilibrium of concurrent forces. Okay, yeah, I should tell that. So, before I teach that, give another heading. Cut this heading or leave one page, whatever you want to do. Common forces in mechanics. Common forces in mechanics. Common forces in mechanics. Okay. So, basically there are so many forces which can be learnt, but in your 11th physics we are going to concentrate on 4 different types of forces which will come again and again here and there. The first force, very convenient force for you, is the weight. Have you heard about weight? What is weight? Very good. That is called as mg, right? Mass into acceleration. Since it is the acceleration by the gravity, we call it as acceleration due to gravity. So m into g. Mg gives the weight. So weight always acts where? Towards the center of the earth. Remember this. So if an object is like this, how will the mg act? Downwards. If the object is like this, how will the mg act? Downwards. If the object is like anyway, always the mg will act how, where? Downwards. Remember this. Mg always acts where? Downwards. Where it is acting? Towards the center of the earth. And this is the first force, which is called as what? Weight. Next common force in mechanics is the reaction. It is called as normal force, or also some books will write reaction force. To every action there is an equal and opposite reaction. So, if the action is mg, what will be the reaction? That reaction only is this normal force. If your book will write n or some books will write r, both are meaning same. One check is there here, one clue is there, a clue or what is it, important concept is there. I said before some time, if the object is on an inclined plane, mg acts how?
But normal actually.
Normal always acts perpendicular to the surface. Write down somewhere. That normal or reaction always acts how? Perpendicular to the surface. Perpendicular to the surface. Example? Example for this force. This is the example only, man. There is a wedge, there is a box of mass 5 kg is lying. Downward 50 Newton will be the weight, 5 into 10, 5g. And this will be the normal reaction. Will it be 5g? Will it be 50? We cannot say like that. It depends upon what is the angle between this and this. So it will have 2 components. We will talk about that. Let that come. Now why you want to confuse yourself? Okay, it will come. I taught these things in bridge course, right? These complicated scenarios. We will learn it here also. Okay, fine. Is it clear to you normal reaction? Normal reaction is reaction to the action. Suppose I am standing on this floor. Why I am able to stand on the floor? Why am I not going down? If I say that there is a force being exerted. Before some time I told you, if the force is being applied, the body will change its state of rest or motion. Until the force is a balanced force. So if I am standing with a force acting downwards, there must be some balancing force.
Yes, sir.
What is that? Normal force. So if I am giving a force of 800 newtons down, the surface is giving a force back on my leg. How much? 800 newtons. If this floor is unable to give me 800 newtons, it will break. Suppose if I stand on this, mostly it will break only. Why? because this plank is not capable of giving 800 newtons of force, because my force will be 800 newtons, upward 800 will not be able to give. So this reaction is a property of the surface where the object is lying, isn't it?
Yes, sir.
That's why I said that it always acts perpendicular to surface, not to the mg. Don't think it acts opposite to mg, no. It acts perpendicular to the surface. Is it clear to you? Third kind of force that you're going to study in this chapter is called as tension. Yes. What is tension? Force into displacement. Not surface tension, Dhammi. Surface tension is force per unit length. Tension I am asking. What is tension? Not only thread, anything, please pay attention. If any string, thread, rope is being pulled, not pushed, then what is the reaction force coming? That reaction is called as tension. Are you getting my point? mg acting downwards, what acts in the rope is called as tension. Once again, if there is a rope hanging from the ceiling, if you are hanging on it, it does not break. If I am hanging on it, it breaks. It means what? The tension in the rope is not high. He may give a weight of only 50 kg.
Yes, sir.
How much? 45?
Yes, sir.
45. So 450 Newton he will give. So that rope is capable of providing 450 Newton of tension. I will give how much? 800 Newtons. How much it has to provide?
800.
Not capable? Break. If it is capable, it will hold. It depends upon the rope's capability. Once again, it is a material property. Are you getting a point?
Yes, sir.
Whether a particular rope or the string is able to generate a tension or not, it totally depends upon the material.
Sir,
Yeah. Tension is the force acting in the opposite direction to a pulling force on a string. There is a string, a pulling force is acting. What is the force acting against it? That is called as tension. To balance it. See, always you want equilibrium, right? If it is more, it will go down. If it is more, it will come up. Not possible, right? A rope is hanging. You hold the rope will pull you above by itself. Is it possible? Until somebody is pulling you by some mechanism, rope will automatically pull you. Not possible, right? You can pull the rope down. You can break the rope also. But rope cannot take you above. Are you getting my point?
Yes, sir.
So if mg is more than t, the rope will break. T can never be more than mg. T can be equal to mg. The rope will be in equilibrium. The fourth type of force which we are going to use in this chapter is called as spring force. It will not be used in this chapter much. It will be used only in next chapter, work, energy and power. Springs are there. So what is spring? What is a spring force? Suppose I am having a spring like this and there is a mass m of the object, and if you try to pull it in this direction by applying a force F, I pull and keep it here. I leave, what will happen?
Go back.
It will go back. I left, the force I applied became 0. But then why the object is in motion? Some force is still there. Which direction? Opposite direction. This force is called as restoring force or spring force, which makes the spring to go back in this direction, and always this spring force will be acting in the opposite direction of the applied force. Imagine I applied a force in this direction and compress the spring. I leave, it will come back? No. I press the spring and I remove my hand.
Yes, sir. It will come.
It will come back, no? Why it will come back? Because when I applied a force in this direction, there is a restoring force or the spring force developed in the opposite direction. That's why it comes in this direction. So spring force is always acting proportional to displacement in the opposite direction. Why I put x? X means displacement. Common sense. If I displace more, more force will come. If I displace less, less force will come. And minus is indicating that spring force direction is opposite to displacement direction. If I displace towards the right, spring force comes towards left. If I displace towards left, spring force comes towards right. Are you getting? So this is the 4 different types of forces we are going to study throughout this chapter, which are weight, normal force or reaction force, tension, spring force. Clear? Okay. Yes. Normal force you are asking. Normal force, I said, it is the reaction force for the action what you are giving by weight. Suppose I am giving action here. What is action? My weight on the floor. Why I am not going down? Opposite direction. That is only called as normal force. You are sitting on the chair, not breaking, right? Why? Because chair is giving a force back on you. How much you are giving on chair? Chair is giving back on you. If you give a force more than chair can give, it will break. Chair cannot give more than you. If it gives, you start flying above. Isn't it? But definitely, chair can break by your force. If it happens, then your mg is more than the reaction the chair can provide. So reaction force on a normal force acts perpendicular to the surface where it is being kept.
Sir, you said that the spring force is directly proportional to displacement, no, sir? So what if we bring the mass around like this and close to the original point itself? So displacement will be close to 0, no, sir? So
Displacement, how it will be 0, man? 0 is this position from where you are starting, right?
yes, sir.
So if you are going, it will become negative. If you go that side, it will become positive.
Yes, sir. So we are bringing it around and coming to close to the original point, sir.
Original point is what? This point.
Yes, sir.
You are pressing or you see, now this point only should be taken as x is equal to 0, right?
Yes, sir.
If you pull towards right, it will become some x is equal to plus a. Maximum a, I am writing a. If you bring this side, it will become x is equal to minus a. So how you are saying I am bringing to 0? You cannot bring to 0, it will automatically come to 0. You are thinking if I compress fully, it will become 0. No.
Not like this.
Ah.
Sir, we are taking it, so we cannot bend it and we cannot find, sir.
Bend?
No, sir. We bend, we should, after bending, if we come to the original point, so the displacement will be 0, or close to 0.
See one thing, I will tell you. When you are pulling it and you are leaving it, do you think it will come and stop here? Never. You may think I gave this much only, no. It will come and stop here, no, but because of inertia and kinetic energy, it will overshoot and go that side. We will study about this in detail in the next chapter. What happens when you are pushing an object? It acquires kinetic energy, and kinetic energy will be maximum here. It will overshoot and go this side. It starts oscillating. Front, back, front, back, front, back. You don't think I am pushing, leaving, it stops here, no. It starts to oscillate. Okay, so I hope it is clear up to here. Any problem? Any problem?
Flexible, sir.
Spring?
Flexible.
Obviously spring will be flexible only.
Sir, the origin spring starting point and the mass and all.
Spring starting point lende mass avuthundi. Ha.
Spring eduthe ipdi vechukunnaru now.
Spring eduthe ha.
Starting point. Spring or starting point.
No, sir. I'm asking if we bring the mass around circle, we make a circle.
Like this.
Starting point.
I compress the spring like this. Huh?
அது ஸ்டார்டிங் பண்ணா அங்க கொண்டு வந்தா என்ன ஆகும்?
Sir, he is asking what if the mass is applied in the this other side of the spring. Yeah.
This is what you are asking. Tell man, yes or no? Huh, draw and show. That is, you are displacing to the not maximum only, no? How you are starting? I am pressing, becoming here, remove it will come with maximum force. Think practically, man. Spring is there, you are pressing little less, removing, it will come. Pressing little more, removing, it will come more. Pressing the maximum possible and removing, it will come maximum force, right? Able to feel it? You have a spring in the pen, some pen, go and try today, not now, later after class gets over. You are having spring, don't do it now, man, later. Shall I proceed further? So, next topic which you already wrote earlier, equilibrium of concurrent forces. You will not let me teach. Equilibrium of concurrent forces. You want to copy down, huh? Tomorrow you will copy. You are asking me or you are saying me? Definitely you should, man, not copy still. What are you doing for that time? Sitting and listening to my talk with Lalit Ramana. That I am doing for you to write only. If you have talking means you should write by that time. Fast. Later you will write. Time is already.
Is it possible to find the spring force when the spring is bent, sir? The spring we are bending like this and hitting here.
If you remove, it will come back, no, bouncing and come back.
So the displacement will be very close to zero.
Okay. So in that case, see, x is not the net displacement. X is how much you are displacing it. You may think I am bringing like this and keeping like this. So my starting ending point are same. Displacement is 0. So in that case, you will not be able to find force by that. No, we cannot find like that. You have to give some displacement for it to find the force. It should not be 0. Can I? Raghav? Yes, my lord. Take next page. These things don't draw. பாதி எப்படி தம்பி இப்போ தான் ஸ்டார்ட் ஆகுது. இருக்குது சில டாபிக்ஸ் இருக்குது. இக்குலிபிரியம்க்கு அப்புறம் வந்து ஃப்ரிக்ஷன் இருக்குது, பேங்கிங் ஆஃப் ரோடு இருக்குது, சூப்பர் எலிவேஷன், motion of vehicles on curved roads, important topic. Okay guys, Raghav, shall I? Okay, give the heading as equilibrium of concurrent forces, which you already gave in the previous time. Equilibrium of concurrent forces. Equilibrium of concurrent forces. First of all, Mr. Arshad, not you man, Arshad on the online. What is the meaning of concurrent forces? What is the meaning of the word concurrent? Any idea?
Oh, yes.
No issues, yeah.
They are on top of each other, sir.
Top of each other? No.
Overlapping.
Huh? Concurrent meaning I am asking, not the force meaning I am asking. Concurrent. Consecutive. Yeah. Single point. When the lines are called a concurrent, you know, when they are passing at the same, these three lines are concurrent. Why concurrent? They are passing through a same point. So what will be the concurrent forces? The forces that are acting at the same point are called as concurrent forces. So it means if I draw like this, these are what forces? Concurrent forces. You will get some question where concurrent forces will be given, out of which one force will be known to you, other forces you should find. Today we are going to learn two different methods by which we can solve concurrent forces questions. One method is conventional method, old type retro method. One method is modern high-tech Lemmy's theorem method. Now you may say, okay, then why teaching old method? Teach Lemmy's theorem directly. Always remember that old things are only more better, right? Yeah, so conventional method is good because it is like it lives in all the places. Lami's theorem will sometimes be little trouble giving to you. I am not saying you cannot solve. You can solve any question by any method, either Lami's or conventional method. It's not like a question can be solved only by Lami's theorem. No. If a question can be solved by Lami's theorem, it can also be solved by conventional method. But I personally prefer the old method. Okay, anyhow, your wish. So, first I will teach you Lami's theorem, the simple one. Lami's theorem says that if it is F1, if it is F2, if it is F3, and the angle opposite to F1 is alpha, angle opposite to F2 is beta, angle opposite to F3 is gamma. Then as per Lami's theorem, F1 by sine alpha is equal to F2 by sine beta is equal to F3 by sine. Understanding this is just a theorem. So, what will be given if suppose only F1 is given to you? Suppose alpha and beta are given to you. Out of the 6 terms, 3 are given to you. F1, alpha, beta. If alpha, beta is given, you can find gamma easily. Sum is 360 degree. If 2 are given, 1 you can find easily. F1 is given, alpha, beta is given, gamma you found already. By these two formula you can find F2, and by these two formula you can find F3. That's all you have to do. A question will be there, F1 will be given, alpha will be given, beta will be given, find gamma, find F2, F3. Looks simple while I am saying, question will be complicated. Okay, this is the concept, but if I am going to use a conventional method, the same kind of question where there are 2, 3 forces there like this and like this, let me name the same F1, F2 and F3, and the angle is given. Angle is given something like this. This angle can be theta 1, this angle can be theta 2, like this angle is given. Obviously, we can find all alpha, beta, gamma from here, because if you take 90 plus theta 2, it will give you beta, 90 plus theta 1 will give you alpha, and this will give you gamma. We can find here from here also angles. But by the old type method, what I will do, I will resolve the forces. It may look complicated to you. How? F1 theta 1, this side it will become F1 cos theta 1. This will become F1 sin theta 1. This side, this is F2, right? Yeah. This will become F1, why I took theta 1, okay, whatever, cos theta 2, and this will become F1 sin theta 2, right? If the object is in equilibrium, if the object wants to be in equilibrium, don't you think that net upward force and net downward force should be same? It means that F1 sin theta 1 or sin theta 2 in this case plus F2 sin theta 1 should be equal to F3, and also F1 cos theta 2 should be equal to F2 cos theta 1. Do you agree with me? This tells the equilibrium of concurrent forces. Again I am repeating, this may look complicated to you, this may look simple to you, but when the question comes you will realize this is also much helpful sometimes. Shall I give a question now? Copy fast, copy fast, copy fast. Copy it fast, then I will give a question before I wind up today's class. Time is going to be 9, but bear 5 minutes more.
Can you repeat one more time?
Which one, Thambi, Karthikeyan?
Where that F1 cos theta.
Okay, I am repeating this. So for you, what I am doing, I am changing the angle itself. I know this theta is confusing you more. I have taken like that. What I am doing, I am taking this as theta 1, this as theta 2. This is F1, Karthikeyan, this will become F1 cos theta 1.
Yes, sir.
This will become F1 sin theta 1, do you agree?
Yes, sir.
This will become F2 cos theta 2. This will become F2 sin theta 2, do you agree? This is clear to you first?
Yes, sir.
Sure?
Yes, sir.
How it came, you are asking? Man, F2 resolving into components, man, here and here. This is cos component, this is sin component. கீழே எப்படி வரும் தம்பி? இங்கே தானே ஃபோர்ஸ் ஆக்ட் ஆகுது. இப்படி ஆக்ட் ஆகும்னா இப்படி தானே வரும். இப்படி ஆயிடுச்சுன்னா அப்படி தான் இப்படி கீழே வரும். Horizontal and vertical components தம்பி. Understanding? So, now the net upward force, Karthikeyan, is how much? F1 sin theta 1 plus F2 sin theta 2, am I right?
Yes, sir.
And what is the net downward force? F3. So, for the body to be in equilibrium, equilibrium means no motion, neither upward nor downward. It means total upward force should be equal to total downward force. Do you agree with me?
Yes, sir.
Same way, the body is not moving towards right or left. It means the left hand side force must be equal to right hand side force. Do you agree?
Yes, sir.
That is what I told you. Copy it fast.
Oh, yes.
Lehm's theorem. Nothing is there to understand is, man. F1 opposite is alpha, F2 opposite beta, F3 opposite gamma. F1 by sin alpha is equal to F2 by sin beta is equal to F3 by sin gamma. Nothing is there for understanding in this. Just remember the formula. And I'll tell you how to use in the question also. When question comes, it will be more easy. You wrote at least. Tomorrow you will write. Man, time is already 9 o'clock. I'll give the question. I'll give the question, guys. Please take the question fast. Already people started dropping because of time became 9. One question before I close the class. You write later, okay? Question is, determine T1 and T2. Determine T1 and T2. There are two strings. It is hanging by a mass of 5 kg. You have to find the value of what and what? Tension in the first string and tension in the second string. T1 and T2. Make it fast. Don't take more than 2-3 minutes. I have to wind off the class also. Give a try. I will help you if you are not able to solve. Don't worry about that. Any progress? Could you get the value of T1 and T2? Yeah, you can come in root also, no problem. It may come in root also, no issues in that. I will solve this question by both method, Lemmy's theorem also and conventional method also. Shall I solve and show you, or you are going to solve by yourself?
Sir, 2 minutes.
Yeah, make it fast.
T1 equal to 100, sir.
T1 is 100 and T2 how much? See, we are already running late, so I will solve this question for you.
100 by root 3, sir.
Let us check. I will solve this question to make you understand. Next question is solve by yourself. So here this is 30 degree, this will also become 30 degree, interior alternate angle. I have drawn a line parallel to the horizontal line. This will become how much degree? This will help you in finding. This will become T2 cos 60. This will become T2 sin 60. Same way T1 is there. This will become T1 cos 30. This will become T1 sin 30. By the same logic what I used in the previous class, previous topic, or while teaching the concept, T1 cos 30 will become equal to T2 cos 60. What is cos 30? Root 3 by 2. What is sin cos 60? 1 by 2. 2 gets cancelled. I get T2 as root 3 times of T1. Do you agree? After that, please pay attention. I have T1 sin 30 plus T2 sin 60 is equal to 50. 5 kg means the force will be how much? 50 Newton, right? Solve this. What is T1? What is sin 30? 1 by 2. T2 I can write as root 3 T1. And what is sin 60? Root 3 by 2. It will become 50. If I take T1 common, it will become 1 by 2 plus root 3 will become how much? Root 3 into root 3 is 3. 3 by 2. What is here? 50. What is 1 by 2 plus 3 by 2? 4 by 2. Am I right? Which is how much? 2. So T1 will become 50 by 2. Do you agree with me? How much is that? Once you get T1, what will be T2? Root 3 times of 25. 25 root 3 is the answer. 25 root 3. Do you understand how the answer came? Any problem?
Sir, we have to convert the...
Convert what, man?
The answer, the T2 answer. 25 to root 3.
Your wish, man. If you want to convert, no, that is not a big deal. Because left and right should be same, no? Equilibrium. Equilibrium. If I solve the same question by using Lemmy's theorem, please pay attention. This angle is how much degree? 60 degree. This is how much? 30 degree. Downward how much? 50 Newton, right? This will become 90. This will become 90. This will become how much? Tell me. This is 120. This fully is 120. This fully is 150. So 150 and 120, it will become 90, no man? Huh? 90 will become 110, yeah, 360. So now what is the formula? Suppose this is T1 and this is T2. What is the formula Lemmy's theorem? T1 by sin 150 is equal to T2 by sin 120 is equal to T3 by sin 90. Not T3, it will be 50 actually. Do you agree with me? Solve and get the answer from here also. Same thing will come, you see. What will be T1? T1 will become equal to 50 into sin 150 divided by sin 90 is 1. What is sin 50? Sin 90 plus 60, which is cos 60. What is cos 60? Cos 60 1 by 2. So what is T1? 50 into 1 by 2 will be how much? Same answer came. What will be T2 by this concept? T2 will become equal to sin 120 into 50 by 1. What is sin 120? Sin 90 plus 30, cos 30, which is root 3 by 2. 50 root 3 by 2 is 25 root 3. Got the answer? The same answer came. Lami's theorem may look like saving time. It may save time also sometimes. But this method is also simple only, not a big thing. Are you getting? Both the methods is clear to you? By Lami's theorem, if you are able to find the angles properly, you can use Lami's theorem. Otherwise, resolve the forces and get the answer. Both are correct. If you are done, if you have understood, and if you have no doubt, you can start moving. Online students can start dropping if you are done with your class. Something you want to ask me, you can ask me. Bye bye. Take care.